Hi all, today in this video you are going to learn about simple stresses and strains. Simple stresses and strains is a topic in strength of materials. Strength of materials is a branch of mechanics where mechanics is the study of forces, energies and their effects on various bodies. In this we are going to learn load and its types, stress strain definitions, stress and its types. What is a load? Load is defined as a set of forces acting on a body or mechanism. Common loads in engineering applications are tension and compression. Tension is defined as the direct pull of an object, that is nothing but the extension. Compression is nothing but the direct push of an object. Here it is called the contractual forces. Types of loads. There are different types of loads such as dead loads, live loads, tensile loads, compressive loads and shearing loads. Dead loads. Dead loads are static in nature. Example, self weight of a roof. Live loads. Live loads are fluctuating in nature. That means they do not remain constant, such as weight of a vehicle moving on the bridge. Tensile loads. A body can withstand before failure divided by its cross-sectional area is called a tensile load. Here, tensile loads are indicated as sigma T. Compressive loads. The maximum load a body can bear prior to failure divided by its cross-sectional area is called compressive loads. It is indicated as sigma C. Shearing loads. The maximum load a body can withstand before failure occurs divided by its cross-sectional area is called shearing loads. Generally, it is indicated as tau. What is a stress? Stress is an internal resistance offered by a unit area of the material from which a member is made to an externally applied load. In other words, stress is defined as the resistance of a material or the internal force acting on a unit area in any direction. For example, let us consider the image shown where A is called the cross-sectional area, E indicates the force or the load and sigma indicates stress. Stress. Generally, stress is calculated by using the following formula, where, as I already said, sigma is nothing but stress. Therefore, sigma is equal to applied load by original cross-sectional area resisting the force. Therefore, we can say sigma is equal to F by A, where I already said resistance force is equal to applied load. Therefore, F is equal to P. Now, include F is equal to P in the following equation. Therefore, sigma is equal to P by A. See, sigma is equal to force by cross-sectional area. That is nothing but F by A. That is nothing but sigma is equal to P by A. Units of stress. Sigma is equal to P by A, where P is nothing but the load. Load is indicated in newtons and A is nothing but the cross-sectional area, where we use here meters. So sigma is equal to Newton per meter square. In other words, sigma is equal to Newton per millimeter square. Some other conversions of stress are 1 Newton per meter square is equal to 1 Pascal, 1 kilonewton per meter square is equal to 1 kilopascal, 1 megapascal is equal to 10 power 6 Newton per meter square, 1 gigapascal is equal to 10 power 9 Newton per meter square, or 1 gigapascal is equal to 10 power 9 pascals. Types of stresses. Stresses are generally classified into two types: tensile stress, compressive stresses, and there is another one called shear stress. Tensile stress is calculated on the longitudinal axis and the lateral axis or transverse axis. There are other stresses called normal stress, longitudinal stress, and shear stress. Let me clearly explain what is normal stress. For example, consider a body of length L mm and the body has two endpoints A and B. For example, if it is cut into two parts with an angle theta, the angle of inclination is called oblique section, where theta is nothing but the obliquity, and the stress that is normal to the oblique plane is called the normal stress. Now, if you consider a body of length L mm again, and if the normal forces are acting longitudinally along the longitudinal axis, then it is called the longitudinal stress. In other words, longitudinal stress is the stress or normal stress that is acting at the cross section. Longitudinal stress is again divided into two types: tensile stress and compressive stress. Tensile stress is indicated in positive sign and compressive stress is indicated in negative sign. And the last one is shear stress. Shear stress is also called as tangential stress. So the tangential stress is indicated as the stress acting tangent to the surface or the plane. So these are the types of stresses you can see. First one is the tensile, the force acting on the both directions of the body along the axis. So this is called the pull of the body. Here the body is pulling in this direction and the body is pulling in this direction. This is the compressive force, where the forces are acting internally along the body. This is the bending and this is the shear. Strain. Strain is defined as when a body is subjected to some external force, there is some change in dimension of the body. That is nothing but the ratio of dimension of a body to the original dimension is called strain. For example, consider the following image. Let us take a body of length L mm and the force F on the both sides of the body. If the body is pulled in both directions, then the body elongates. That means there will be some change in length. That change in length is nothing but delta L. As I already said before, strain is the ratio of change in dimension to its original dimension. Now I will indicate as strain is equal to change in dimension, that is delta L by original dimension L. Therefore, strain is indicated as delta L by L. Here strain is dimensionless. How? Here both lengths are in same units, that is meters. As both units get cancelled, we'll get strain is dimensionless. Thank you.